Welcome to episode 9 of our Design Patterns in Java series. So far, we have explored patterns that help with creation and structure, but now we're turning to behavioral patterns, patterns that define how objects interact. Today, we'll learn about the observer pattern. It's foundational for building systems where objects need to respond to events or changes in other objects, a core concept of UI frameworks, data binding, reactive programming, and even microservices. So what actually is the observer pattern? The observer pattern defines a one-to-many dependency between objects so that when one object changes, all its dependents, the observers, are notified automatically. It promotes a publish-subscribe model. The subject publishes events or changes, and observers subscribe to receive updates. Some use cases are event systems, UI buttons, keyboard listeners, data synchronization, model view binding, notification services, stock ticker alerts, chat messages, YouTube. When I upload an amazing video, you guys get a notification. And we even have reactive architectures like streams and signals. So for this example, I've chosen a weather station. So let's imagine a weather station that broadcasts temperatures updates all day long. So let's imagine a weather station that broadcasts temperature updates. Multiple displays want to subscribe to those updates. One for the current temperature, another for showing statistics, and another for alerts. The weather doesn't care who listens, only that it needs to notify them when the temperature changes. So let's dive into the code, and for that I need to be small so you guys can actually see all that beautiful code. So first we define our subject. And the subject is an interface, and it has three methods. It has register observer, remove observer, which we didn't use, but it's, if you don't want to be subscribed anymore at a certain point, it's very nice to be able to do that. And you have notify observers. Then we have our observer, and our observer has an update method, and it gets a float temperature passed into that. Very simple. All the observers have to implement this to be able to receive updates. Now we have our weather station. So this is our subject. Our subject has a list of observers, which is just an array list of observer. And we have a temperature. Now we have a method called setTemperature, and then the temperature gets changed. And then we notify our observers by calling the notify observers method that is in the subject interface, right? So what actually does notify observers? It loops through all our observers in this array list, and then it calls the update method with our new temperature. We also have a register observer, which just adds an observer to our array list, and we have remove observer, which just removes an observer from our array list. Now we have a temperature display, which is an observer, so it implements the observer interface. And what it does, it just prints the current temperature whenever it gets updated, right? Very simple code. It just implements the update method. The same goes for the alert system, but the alert system is different because it actually implements the observer interface and it implements the update method. But what it does is only if the temperature is higher than 35 degrees Celsius, then it prints an alert. So there are two observers that actually have two different implementations, but both of them are observers and they frequently get updates whenever the weather station sends them updates. So now let's go to our actual code and go over it. It shows how the observers automatically react to changes in the subject's state. The station doesn't know what the observers do. The only thing it does is send the update. So let's run this code real quick. We have created two displays, we have created two observers and we registered them. So we register the observers and then we set the temperature. See how we don't call any of the other methods? We just set the temperature, and then when set temperature is called, it calls notify observers, and they all get sent a new message with the new temperature. So let's run this real quick and see what it did. We have, if we go back to main, please. Yes, thank you. So here we have our current temperature, which is 28.4. Then we change the temperature to 36.1. And you see what it did here, right? Current temperature, 28.4, and it didn't print an alert. So now we have changed it to be higher than 35 degrees Celsius. And now we print the current temperature because this one is the first in the array. It gets the message sent to it first. And then this one prints an alert because it's above 35 degrees Celsius. So it says, hey, alert heat warning. It is now 36.1 degrees Celsius. And that's basically it for the observer pattern. It's a very simple, straightforward pattern that makes sure that you can send messages to everyone that thinks that message is important to them. So what actually are the benefits? It promotes loose coupling between objects. It scales well, add new observers without modifying the subject, and is great for building event-driven and reactive systems. So what are the limitations? Notification order is not guaranteed. In this use case, it actually is, because as you can see here, we just register them to an array list. But just imagine it being sent through a HTTP request instead of running this very simple example, or something like RabbitMQ where the messages get sent to a bus and the bus sends it to all its observers, and you don't know which gets it first because it could be on a distributed system. So you will never know. There are also some risks of memory leaks if you don't unregister them properly. Then the object will always exist, and you don't want that. So be sure to unregister it properly. It's also very difficult sometimes to trace event flows in large systems. You don't know where all the events go to, you don't know who's subscribing to what, especially if your code base grows or if the system grows. So not even your code base, but maybe someone else's code or maybe a whole different application subscribes to your stuff. And to trace all the events in that system, it gets really hard and difficult. Now, some best practices. Keep the update interface simple and very specific. Consider observer priorities if execution order matters. Use weak references or unregistering strategies to prevent memory leaks, and avoid overusing this pattern for trivial cases because that's just over-engineering for no real use case. To recap, today we learned how to use the observer pattern to allow objects to subscribe to and react to changes in another object's state. This is a vital pattern in real-time systems, Flag UIs, and anywhere reactive behavior is needed. And in the next episode, and the final episode, we'll explore the strategy pattern, which allows algorithms to be selected at runtime. So don't forget to like, share, and subscribe for the final episode, which is episode 10. Be sure to have a great day and happy programming, and see you in the next one.